Hey everyone, let's take a look at the first one in section 4.7. We've got a rectangular bird sanctuary that's going to be created with one side along a straight river bank. Okay, and then the remaining three sides are to be enclosed with a protective fence. Um, if there are 12 kilometers of fence available, find the dimensions of the rectangle to maximize the area of the sanctuary. So I've got a river roughly straight running through this area, and we're going to enclose a rectangular area here called a sanctuary for these birds. Put a protective fence around it, assumed to protect the birds, since the birds can fly out of it. Um, and so dimensions, what are dimensions of this rectangle? Well, we've got maybe call this the width. I'll call this X. This is the side parallel to the river. And then Y maybe is if this is the width and this is the length, or length and width, I don't know which is which. But Y would then be the perpendicular fencing perpendicular to the river. Okay, so what are we going to do? We want to find the dimensions of this rectangle to maximize the area of the sanctuary. So what is the area? Let A be the area. Area is just length times width, so X times Y is the area. And so how do I maximize that? Well, I can't choose X and Y to be anything I want, as big as I want, because we only have 12 kilometers of fencing. So how much fencing do we need here? We don't need any fencing along the river, so it's just Y plus X plus Y, or X plus 2Y. So X plus 2Y equals 12 kilometers. That's the constraint that we have on the problem. So I can now solve for one of my variables and plug back into my area function to get a function of one variable, which is what I need in order to maximize it. So solving for X is what I chose to do here, or sorry, solving for Y is what I chose to do here. Um, so I subtracted X from both sides and then dividing both sides by 2. 12 divided by 2 is 6, and then X divided by 2 is 1/2 X. Now, X can be anywhere technically from 0. Of course, what does it mean that X goes to 0? As X gets smaller and smaller, the Y lengths get longer and longer, and eventually we have two Y lengths of fencing coming out from the river side by side. Of course, since there's 12 kilometers, they would each be 6 kilometers long. Okay, not a good arrangement, right? That will clearly not enclose the maximum area. In fact, the area in that case would be 0. The other extreme is we can let Y get smaller and smaller. As Y gets smaller and smaller, X gets longer and longer, and as Y goes to 0, eventually X would become just one fence, 12 kilometers long, right along the riverbank. And you can see that here. If I let Y go to 0, X is 12. So that's the maximum X can be. And so basically, I can plug in now for Y here, this expression 6 minus 1/2 X. So when I plug that in, I get this, and distributing the X through, I get 6X. X times 1/2 X is 1/2 X squared. And so this is valid on this interval, right? On the interval from 0 to 12 for X. So basically, we're now asked to find what's the maximum value of this function, right? We're trying to maximize this area. What's the maximum value of this function on this interval? So since we have a closed interval, we're going to find critical values for the function on this interval, and then we're going to check the value of this function at these two endpoints, which we already know it's equal to 0, right? We talked about that. Uh, and then at the critical point. So what is the derivative of the function? Well, pretty easy. Derivative of 6x is 6. Bring the 2 down, I get negative x here. So when is the derivative equal to 0? Well, clearly when x is 6. And if I do a table of values here, right, checking the endpoints, the area, of course, is 0 when x is 0. And when x is 12, it's also 0. That's the situation where we had the fences right along the river in one case, or two perpendicular fences extending from the river. You can plug back into this function to see that that gives us 0 for those values of x. When x is 6, if I plug in 6 here for x, I get 18. And so that obviously is the maximum. 18 square kilometers, of course, for the area. So when x is 6, of course, kilometers, then we're going to have the maximum area. What's the corresponding value of y in this case? Well, we know this relationship. If I let x be 6 in this case, I get 6 minus 3, or 3. And so what are our dimensions? Remember, x was the fence that is parallel to the river, and why are the two lengths perpendicular. So the length of fencing perpendicular to the bank is going to be 3 kilometers, and the length of fencing parallel to the bank is 6 kilometers. Hopefully this is helpful and makes sense.